Lesson 80, direct variation as a ratio and inverse variation as a ratio. All right, starting with direct. When a problem states that variable x varies directly as variable y, we know that the relationship implies this: x equals k times y. So k is what we're multiplying by, so when x is this, it's increasing by this much. So we multiply when it's a direct variation, we divide when it's an inverse variation. All right, so that's the first step. So now we're going to take it a step further. A varies directly as B. If A is 50 when B is 5, what is the value of A when B is 7? All right, so we're saying A equals K, some quantity, times B. If we use 50 for A, we just plug things into our equation and solve for K. Okay, once we know what K is, well then here's the relationship. A equals 10 times B. We're asked to find the value of A when B is 7. Oh, okay, so this is the second part of it. So we've done these before. We solve for K, so we know what we need to multiply by to solve for A. Okay, which K is 10, so when it's 7, then when B is 7, then A is 70. All right, there's another way to work this problem. I don't know if this is cutting off here. Because the statement that A varies directly as B also implies that A1 over A2 equals B1 over B2, which is a ratio. Note that both A's are on the same side and that A1 and B1 are both on top. So we've been given initial values of A1 and B1 of 50 and 5 and a value of 7 for B2. If we insert these values, we get this equation. Now we just cross multiply and solve for A2 and we get 70. Okay, I actually think this is easier because then you don't have to remember, oh, what's K and where does K go? But you can do this either way to solve. It is important to understand that there are two ways to work these problems. Some authors of upper level science books use the first approach, whereas others use the second approach. So that's why they've shown you both of them. Okay, cost varies directly as the number purchased. If 12 can be purchased for $78, how much would 42 cost? All right, so we're setting up a ratio problem. So the cost of the first one over the cost of the second equals the number of the first one over the number of the second one. Or you could do C equals K times N and figure out what it is that you're what's the variable or the amount that you're multiplying by. When C is this, then we multiply the N by this. Okay, so if we set it up as the ratio problem, okay, it says cost is 78. How much would 42 cost? So we don't know the cost of the second one. 12 costs 78, so 42 costs some unknown. We just cross multiply to solve. Okay, now let's talk about inverse variation. If A varies inversely as B, the following equation is implied. Okay, so this is where we're dividing. A equals some number divided by B. Okay, so we can also use the ratio A1 over A2 equals B2 over B1. Okay, so notice the difference here. You're switching your B's around. So it's still A1 over A2. The A's are still on the one side, the B's are on the other side, but now it's flip-flopped. So B2 goes on the top, B1 goes on the bottom. So blues vary inversely as yellows squared. If 100 blues go with 2 yellows, how many blues go with 10 yellows? Okay, so we can use either one of these to solve. Let's take a look at, you already know how to solve it the first way. Let's take a look at the new way. Okay, so it says 100 blues go with 2 yellows. Okay, why are these squared? Let's take a look here. K equals Y2. Oh, as yellows squared. Okay, I missed that part of the problem. Okay, so that's why the yellows have a little 2 after them. So if there's 100 blues, how many blues go with 10 yellows? That's our unknown. So if we have 10, okay, because this is inverse, so now we've got to put our Y2 on the top. 10 squared over 2 squared and solve. So 4 is our answer. We're just cross multiplying. Okay, so that's it for lesson 80.